Welcome back to School of Civil Engineering. This is Hedratullah with another new video. In our previous lecture, I have just shown you that how we'll pass our beam column connection or beam connection, right? But we have seen that in our base plate they have some problem. Okay, in our base plate they have some problem. They are not passing every base plate are failing. So in this lecture I am just going to show that how we'll pass that problem, or how will pass that failure, base plate connection failure. Okay, so before starting that process, if you're new to our channel, then subscribe to our channel and also press the bell icon so that you get every update ever first, because your subscription, your like, your comment or your share inspire us for the next work. Without your support we can do anything here actually. So first of all, we're seeing that all of our base plate are failing. So first of all, I will simply right click on it, and here it's for that. Here we're seeing that for that for that 4 combo it's failing. Okay, for that 4 combo it's failing. Which types of failure? And see the ratio actually here. This ratio is very high. Here, base plate thickness. Okay, it's failing because of base plate thickness. It's failing anchor rod strength, so it's failing manually actually for base plate thickness and anchor rod. Just see here, this is the anchor rod. Okay, this is the anchor rod. Okay, here is the anchor rod, and here is the base plate thickness. Okay, this is the base plate thickness. Okay, here the base plate, and here is the welding, so it's not failing for that welding with base plate and column. Okay, so here it's clearly it's showing the welding, right? And you can see here this is the welding. Okay, this is the welding, and the weld size is 150 millimeter. Okay, and anchor bolt type and number of anchor bolt. So as it's failing for that base plate thickness, so we'll just go for it. So first of all, I'll click on override. Okay, and here from here we'll change the plate thickness is 25 milli. I'll just give 30, then I'll click OK. Now see, it's not even passing. Okay, its ratio is still now 1.19. So again I'll go here and I'll just give the previous what was that actually. I just give here 20, and I'll go here, it's 1.78. so I'm sure if we increase the thickness more, then it will work. So here there's 30. If I give here 35, okay, then if I click OK, now see what happened. Now see that have already passed. Okay, for that combo, and this combo will also passed. It's almost in the 1.02. okay, I'll go here, and there is 35. If you go 40, maybe all will pass because of thickness failure. 40, then click OK. Now just come here, just see here, they have passed perfectly. Okay, because of where the failure was because of thickness, then it's failing. Now we'll go for the rod, anchor rod. So the anchor that is okay, the minimum rod size, this is the rod size 25, and if I increase 32, and see here that is 71. Okay, 17.72. now if I increase that, now see what happened. Okay, the anchor rod size, then click OK. Oh, just go to up. Now see here, it's up reduce anchor rod strength, it's 10.42, right? 10.42. So again we'll go here, and if I go here in bottom, this is the bolt clearance, the offset, maximum offset, increment pedestal, the pedestal material, welded material, and what is the minimum value of N? 75. So if we increase that little bit more, 38, then click OK. Now it's 7.6 and 7.6. okay, it's 7.6 and 7.6. so here anchor bolt strength, I will again click override. So here length is a 500 millimeter. If I increase that 1000 millimeter, now see what happened. Click OK. It's 7.6 also, override. It's 500 millimeter. It will be okay if we are able to use anchor rod material, anchor rod head and nuts square. It will be okay if we are able to increase the number of bolt anchor rod. Okay, the 500, then okay, 7.6. so it's anchor rod material as the 36 and 50 if we use 55 grade. Okay, then click OK. Now see here it's 5.9, it's decreasing. So again if we increase that 105 grade, then click OK. Now it's 4.2, it's more increasing, and here the rod anchor rod head and nuts square, heavy square, and it's square. If we give here heavy square, then click OK and come here, it's also decreasing 3.6. Where the heaviest square, that was if we use hex. Okay, it's 5.3. no, it's increasing. So actually this is the process. In our previous lecture you have seen that. Okay, it's work like that way. Then heavy square, it's we can use heavy square, it's okay. And after that welded material, welded with increment ND. This is the offset length LEV. Offset A, bolt clearance C. What is the bolt clearance? That is also okay. Height 25 with increment ND. Heavy square M30. And now the another option will increase actually our that S1, S2, N and B. Okay, so actually we'll increase our plate thickness, right, and see what happened. I mean plate size B and N. So this is the 250 mm, that size was 25, minimum width and minimum, and 250. If we give her 350, sorry, 350, and also that is 350. Now see what happened. Okay, it's 3.62. Embedded length, then welded thickness, it's also okay. They have no issue with welded thickness. The plate material, if we increase the plate materials, is also okay. Welded material, pedestal material, this is the concrete grade is 400 psi, and width increment ND max, this is the maximum width, that is the maximum width. So if we more increase that, if we use 500 mm plate and 500 mm plate, and then click OK. 3.62, and also base plate thickness, it's failing because of that. Okay, actually we have to increase that plate. Now it's, just see here, now our failing criteria have changed, right? Now our failing criteria have changed, and it's now failing concrete pulling strength. Okay, concrete pulling strength, and also it's now concrete pulling strength, it's also failing for that. Okay, so I'll just go over it, and we'll give 250, and also if we give here 250 as per our previous, then okay. Now it's concrete pulling strength, concrete pulling strength. Now it's failing not for bolt, it's failing for concrete pulling strength, so we have to change that. Actually this is the way actually to change that parameters, that how it's working or not, and at which way it will work. Actually when it's done, I mean when it's all work have done, and you are seeing that they have after completing many tasks it's not working, then you'll simply click OK, and after that you'll go ahead design, then still connection design, then view preferences, and from here for column footing design you will change data from here. Okay, you will change data for here, and before that must you will delete your design data from connection design. After that you will change the data from here. Okay, you will change all data from here, and then click OK, and I have done, and after that we'll simply click OK here, right? So after that when done, then you will again go for here, simply you will go for start design check. Okay, after that simply right click. Now check what is failing. Here we are seeing that they have two things are failing actually when you have changed there. It's base plate thickness, and another is base plate thickness also. When we have changed the data, now it's telling us about the two failure, base plate thickness. So here again I'll just go here, and it's 40, right, as it is 40, and I'll just give here 45. Now see what happened. 45, it's also failing base plate, then I'll just go, it's failing for base plate thickness. When it will tell us about base plate thickness, then 15s, then okay, then it's okay, but it's not okay, then I'll just give here 55, then it will may okay. Just see here all of our work is okay now, I mean our that foundation is okay now. Now the question is only will increase the thickness here? No, will not increase thickness here. So when if I go in, if I click OK, now if I go in summary, just see here, this is your parameter, and here is the summary of our work. Okay, this is the summary of our work, right? So that have passed all of concrete bearing strength pass, base plate thickness they have passed, and here is the data geometric property. But I'll close that, and here I'll go details. So from details you'll be able to see at which data who are related. So from here, if you study here for detailed study concrete bearing strength, then if you see here, this is the base plate area. Okay, then here is the bolt and plate weld materials property. Actually here everything is given here, right? Base plate, okay, then concrete bearing strength, here everything is given actually. So when you will study that in details, and I hope your wall, there's a concrete bearing strength, all of your confusion will be clear and you'll be able to design that perfectly, right? So it's done, then simply click OK. So just see here, it's a passed. Same way you have to right click here and see for what it's failing. It's failing concrete pulling strength, and base plate thickness. So I'll just go here. Now from here we'll give 45, then OK, then see it's OK. Now they have two problem, and it's showing us the ratio is 4.4. and if we see details, okay, if we see details, go down, base plate area, concrete bearing strength, base plate thickness, so its ratio is okay. Concrete bearing strength is also okay. Then base plate area, so we're just seeing that they have only two failure, okay, about two failure here available, that are concrete base plate failure. And if you study that, okay, if you study that, your confusion will be clear. And they have another concrete pull out strength. Just see here, this ratio is not okay. So what is the concrete pull out strength? Actually they have is not sufficient. Concrete pull out strength is not sufficient, right? So here here is two data, and here P and phi NP. So the phi NP is 97.78. and how we'll calculate the phi NP? A is the data given, we need some data FC prime, then here is data, and here is the phi, and it will be automatically calculated by our software. And here is the A BRG. Okay, so with respect to that data, just we have to find out that the value of phi, right? And the that value of phi, that should be more, okay, that should be, this is the P is the meaning of the pressure coming on that, or the force from the structure, okay. And here just you have to work with that area. So if we increase that area or given, okay, if we increase that area, and then I hope it will be okay actually. So let me check, is that data of area is given here or not? AR 1.7 inches square, this is VRG, okay. So here you are seeing that similarly if we increase the VRG, then our that value of phi NP will increase, okay, and or the ratio will decrease. So if I close that, and here it's showing us failing, this is only failing for concrete pulling strength. What is the meaning of that? This is the meaning of that, when the rotation will work or moment will work, then it will try to pull out the plate. Okay, so if I come here and from here to the heavy helix, if I go a square, then see what happened. It's 3.62, right over it. Actually, this is the way to change that data actually. So if we increase that data and then see what happened. 750, then 750, then click OK. Now see here, it's a decrease 2.06. okay, so it's a decrease 2.06. so if in this way, if we change data from here, okay, this is the thickness of actually this is the N and B. okay, this is the thickness of that. So there is the one way, and if we increase A and B, value of A and B, then see what happened again. Value of A, and it's given 50. If we give her 100, and also if we give her 100, then see what happened. Okay, now see, it's a decrease more than previous, right? It's a decrease more than previous. Again, I'll just come here, and from here I will increase here the bar. It's okay. The heaviest square, it's also okay. And from that plate, if we increase the value LEAs, also if we give 100, and also if we give 100, then see what happened, and click OK. Now see, now it's increased. Okay, now it's increased, so I'll just overwrite. Okay, and from here I'll give them 50, and I'll just give them 50, right? Then OK. Now it's decreasing. So actually, in that way you have to change all data as per your requirement, and after that you have to design that. Are you clear? So if you change that data and if you try for some time with your structural knowledge, then it will be okay. As our video being very lengthy, that's why I'm not going to do that. Okay, then after that click OK. So that was the process to design our connection. Okay, in this way we can design our connection perfectly, and after that in the next video I will show that how we'll find out its detailing and how we'll print that. Okay, so thank you very much. Stay connected till next video.